Alrighty, we're going to do a review key, so here we go. Number one, we have to identify the graph as skinny, wide, or normal when we're done, and make a sketch and write an equation. So on this one, we have a reflection. So we have our RST, we have the reflection over the y. So that means that there is a negative with the x. And we have a stretch on the vertical by 3. And it's down 1, right 3. So we start building this here. We have y equals, if it's right 3, that's going to be x minus 3. Put parentheses right around that right away and lock it in so that you don't make a mistake. Then it's going to be down 1, so we have a minus 1 on the outside. That's a boss, vertical outside same. And then a vertical stretch by 3 means that there is a divide on the y side. So that would be a 1/3 over here, but when I move it over here, it's going to be a times 3. So I'm going to get rid of that. And then there's a reflection over the y, so there's a negative with the x, and I always do this, I don't leave enough space. So I'm going to move some of this stuff over. And there's a negative with the x, so there has to be a negative over here, but it can't be right on the x, so I have to have double parentheses, and it is to the 3rd power. So clean that up a little bit. We have y equals 3, double parenthesis with a negative, x minus 3. That's all to the 3rd power, minus 1. So I'll make a little sketch of that. We are going to have a vertex now of 3, negative 1. So we're going to go to the right 3, down 1. There's my vertex. It was reflected, so it is a backwards one. So it's been reflected, and it is a vertical stretch, so it's a skinny one. So again, it's just a sketch here, it's not perfect. I would like to see it labeled skinny, wide, or normal, and the vertex labeled as well. So the vertex here is 3, negative 1. Okay. Next one, we have absolute value function. It is left 2, up 3. So in this case, we are going to go left 2. So that is y is equal to, left 2 would be x plus 2. Put parentheses right around that. And up 3 means it's plus 3. That's a boss. Is that right, Alex?
Yes.
Okay. So we boss it up right there. We got the plus 3. And now we have a reflection over the x. So there's a negative with the y. So that's going to be a negative with the y here. You move it over, it'll be outside the parentheses. And there's no scale change. So if I clean this up a little bit, I do my final draft. I have y equals negative outside of the parentheses. Wait a minute, it's absolute value. So I'll put absolute value instead. X plus 2 plus 3. So because the negative's on the outside of the absolute value, it's actually going to make it upside down. So we go left 2, up 3. And it's going to be an upside down one. New vertex up there. Upside down absolute value function. There's no scale change, so it's not skinny or wide. It would just be like a normal parent function. Vertex negative 2, 3. Okay. Bada bing. What's going on, guys? Bada bang, bada boom. You forgot the bang. We got some creeps in here taking a test, so I'm sorry if I'm interrupting you, but this is my prep space, so anywho. All right, number 3. What do we got here? Parent function is a parabola. So this one's not moved right or left at all, so there's nothing going on with the x, but it is down 6. So I'm still going to put parentheses around the x just because I don't want to make a mistake. Down 6 is a minus on the 6 on the outside. vertical compress by 4. So that means on the vertical side, compress is multiply, MC. So I multiply by 4 there, but when I transfer it over to the other side, it becomes a fraction. So it is a divide 4. Okay, so now it's gone from there and it's on the right side. There's no reflections, so there's no negatives, and it's just moved down 6. So I'll put my final answer down here. I'll clean it all up. This would be 1/4 outside of the parentheses, x squared. Technically, you don't need the parentheses, but I think it's good practice to have them in there. And then minus 6. So on this one, it's going to go down 6, and it's going to be vertically compressed, which is going to make it wider. Are you guys taking a transformations quiz? Is this like helpful? No? Yeah.
Mr. Staub is awesome.
Mr. Staub is awesome. Don't forget that. All right, so we got a parabola, and it's going to be a wide parabola. I won't make any comments. Okay. What's the vertex there? So that's wide, and the vertex is going to be at 0, -6. Again, you look at the vertex, you look at the equation, the x stuff should be the same, the opposite, and the y stuff should be the same, right? So right here, if I highlight this y stuff, that should be the same in the equation as it is in the vertex. And the x stuff, well, this one's 0, and of course you don't see anything in there on the x. All right, number 4. Parent function is absolute value again. There's no reflections, so it's not going to be an upside down one. It's a horizontal stretch, so a horizontal stretch is going to make it wider. And it's right 4 down 2. So let's go. We got y equals. Horizontal stretch means it's going to be a divide by 2 on the horizontal or a times by a half. I like to do times by a half. So we'll go 1/2 times. It's moved right 4, so that is x minus 4. And down 1. So on the outside of the absolute value, it's going to be a -1. Okay. So right 4, that's -4. Down 1, that's -1, and 1/2 is the horizontal stretch. So giddy up. Do a little sketcheroo with that. -4 makes it go to the right 4. And -1. So my vertex now is going to be at 4, -1. You double check your work on your tests. I was talking to the audience, sorry. If you have time, you do. Okay, good. So let's just double check our work because I have tons of time. 4, -4. Hi-yo, horizontal inside opposite. Bada bang. The other one should be a VOS. That should be vertical outside same. And there you go. Outside same. So make a little sketch. We got absolute value function. It is a horizontal stretch, so it should be wider. All right, crepes, that takes care of page number 1. Now let's do the other direction, describing it in words. So now we're given the equation. So any reflections in this one? Yep. There's a negative with the y, so it reflects over the x. Okay, how do you know that negative's with the y? It's not in the parentheses. I've said this like a million times this unit. Okay, any scale changes? Looks like we have a multiplication, but technically it's a division because it's over on the y side, so it's actually a divide over there, right? So the y would actually be divided. So that means that it is a vertical stretch. So vertical stretch by 4. And then the translation, it is gone to the right 5. Sorry, 5. I don't know why I said 5. Probably 3, right 3, and up 2. Okay, so my vertex again should be right 3 is positive, up 2 is positive. So the horizontal stuff should be the same. Sorry, I said that wrong. Horizontal stuff should be opposite, high O, and the vertical stuff should be the same. And it is. So we checked it and it checked. It's good. All right, then you can make your little sketch. So we go right 3, up 2. There's your vertex. Reflects over the x, so that means it's going to be an upside down. Right? Anytime you reflect over x, it's upside down one for parabolas. And that makes sense because the negative is on the outside there, so it should have an impact. Where if it's inside and it's squared, it becomes positive anyway, and it doesn't do anything. So this will be an upside down parabola. It's vertically stretched, so it's going to be a little skinnier. So we'll label it skinny. All right, moving along. Any reflections on number 6? Yep, there's a negative. It's outside of the parentheses, so it's actually with the y, so we reflect over the x again, which means this is going to be an upside down absolute value. Scale change, there is a division, but if we move it back over with the y, it actually is a multiplication by 4, so we consider this a vertical compression, which is going to make it wider, which makes sense because if you times it by 1/4, it should make it smaller, which makes the y values all smush down and the graph widens out. The translation is going to go left 2, down 1. So the vertex would be -2, -1. Double check that again. Verticals are the same. Horizontals are opposite. Good deal. So I'll make a sketch. It's right here. It's going to be an upside down one. It was a vertical compression, so it's going to be wide. Okay, next one, we have a reflection again, but this one it's inside the parentheses, so the reflection is there's a negative at the x, so we reflect over the y. It's a cubic, so anytime you reflect a cubic over either one, it's going to be a backwards one. So it's going to look like that. Scale change, there's a divide on the horizontal, so in this case it is a horizontal divide, ds, divide stretch, horizontal stretch by 2. And the translation, it does not move right or left, but it does move down 3. So the vertex is 0, -3. Double check our work there. The x stuff is 0. There is no plus or minus there, and the y stuff is the same. So vertical outside same. Okay. So this vertex is down here at 0, -3. It's a backwards one. Horizontal stretch makes it. Hey, what does horizontal stretch make it? Come on, you're taking this test right now. 55. What does it make it? Horizontal stretch. What does it make it? Wide or skinny? Nice. Wide. We're giving this kid tips, right? This is the perk you get to be taking your test in my prep area. So that is a wide one. Okay, bada bing. That was probably really loud. Sorry. On the AirPods, that was probably really loud in there. They're gonna be that's their wake up call because they've fallen asleep by now, probably. Yeah, I hear you. If you guys have trouble sleeping at night, just tune into this. It's on my YouTube channel. Put you right to bed. Reflection, none. Okay, some people say, well, what about this negative? That's a minus. It's not a negative times, so don't reflect. That's not a reflection. Okay, scale change, there's a 2 times on the outside, so really that's a divide by 2 on the other side, so it's a vertical stretch. So vertical stretch by 2. And it's not moved, it is moved right 4. It's a -4, so we got right 4, but not up or down at all, so it is just 0 for the y. So my vertex is going to be +4, 0. Double check that. Those are opposites, horizontal inside opposite. And the other one is the y, and that's the same, vertical outside same. Okay, good deal. Here we go, 4, 0, 4 to the right. It's going to be vertical stretch by 2, so it's going to be skinny, and there is no reflection. Okay. All right, that brings us to 9 and 10. I already did these questions in a different video, so I'm going to skip those. You can watch those later. 11 and 12, we'll take care of these. This is where we are writing an equation and solving for the scale change. So we have y equals a times, now what happened at this vertex is it is -1, 2, so it's really left 2. So inside on the x we do the opposite, so that's not -1, it's +1. It is a cubic, so I'm going to put it cubed in there. And it is up 2, so I'm going to add a +2. Now what I have to do is just plug in the other points. So I'm going to plug in -3 for x, -6 for y, make those substitutions and solve for a. So we have -6 equals a times -3 plus 1 squared cubed. That's where everyone makes a mistake. Everyone forgets about this right here, and they make the mistake on the exponents, so be careful on that. All right, -6 is equal to, what's -2 cubed? -8 plus 2. Subtract that over, I'm going to get -8 equals -8a. So lo and behold, a is equal to +1, which means there was no scale change. So it's a normal one. Y equals x plus 1 cubed plus 2. Okay, the other one looks like it's been reflected. So this one should be a -a. It's been reflected, and that kind of looks skinny, but I'm not 100% sure, so let's solve. We have a, and if it was skinny, I would expect it to be a vertical stretch. So if it was a vertical stretch, there'd be a number bigger than 1 out in front of the parenthesis. But let's solve for a and confirm that. So we have y equals a times the vertex is 3, 0. So that means that's a -3 on the x. And plus 0 means I don't have to do anything on the y. So I just put the cube in and I'm good to go. Make my substitutions now. So I'm going to put 1 in for x, 32 in for y. So I have 32 equals a times 1, 1 minus 3 cubed. 1 minus 3 is -2, -2 cubed is -8, so I have 32 is equal to -8a. So a is -4. So I was right. Haha. Of course I was right. I'm always right. Just kidding. So now we have y equals -4. So it's been vertically stretched and it's been reflected over the x, and it was just x minus 3 cubed. There we go. On to the last page. 4 problems to go. We can do it. You can do it. All right, now we're going to look at specific points. What happens when we translate specific points? So in this case, we have x plus 5 inside on the x. So if it's plus 5, that's the high O part, right? And so my high O is horizontal inside opposite. I'm going to minus 5 to every x. So minus 5 to every x, minus 5. Okay? So negative 2 minus 5 is going to be a negative 7. 4 minus 5 is negative 1. 6 minus 5 is 1. So all those change like that. And then the outside, vertical outside, same. So in this case, if it's plus 1 on the outside, it's plus 1 on the y. So all these are added to 1. So negative 2 plus 1 is negative 1. Negative 6 plus 1 is negative 5. And 2 plus 1 is 3. And then I'll let you sketch these because I'm running out of time. 18, we have a couple things going on here. We have a negative, and we have a plus 2 on the x. So that's the high O stuff. So if we have we're going to do our pluses and minuses first, kind of like reverse PEMDAS. So if it's plus 2, it's actually minus 2. And then I'm going to divide it by negative 1, which I know is the same as times, but I'm being very thorough. So each x is going to subtract 2 and then divide by negative 1. Okay, so negative 2 minus 2 is negative 4. Divide by negative 1 is positive 4. 4 minus 2 is 2. And then divide by negative 1 is negative 2. And then 6 minus 2 is 4. Divide by negative 1, you get negative 4. So there's all your new x's. Then vertical outside, same. What happens out there? It's a minus 4, so then that does the same as what you normally think it does. So with the VOS stuff, that all subtracts 4 to all the y's. So negative 2 minus 4 is negative 6. Negative 6 minus 4 is negative 10. And 2 minus 4 is negative 2. There you go. I'll let you graph that. Same type of thing over here. It's getting a little repetitive. On this one, the high O stuff, all these points, you're going to subtract 1. So you do the opposite, so plus 1. So it says minus 1. And then if it's times 2, you're going to then divide by 2. Okay, so all of them you're going to minus 1, divide by 2. So if I subtract 1 from negative 2, I get negative 3. Divide by 2, I get 3/2 or 1.5. 4 minus 1 is 3. 3 divided by 2 is 1.5. Actually, that should be a negative 1.5. This should be a positive. 6 minus 1 is 5. 5 divided by 2 is 2.5. Okay, and then the x's, I just do the y's, I do vertical outside same, so I'm going to minus 3 on all the y's. So minus 3, minus 3, minus 3. That's going to give me negative 5 there. Negative 6 minus 3 is going to give me negative 9. And 2 minus 3 is going to give me negative 1. So kind of ugly values on that one. This last one, I only have one thing happening on the horizontal. So there's a minus 1, so horizontal inside opposite, I plus 1. Plus 1 to all the x's. And then the vertical outside same. This one is going to have two things. The VOS, I'm going to add 3 and times by negative 2. So for all those verticals, for all the y's, I'm going to add 3 and then times by negative 2. So that negative 2 plus 3 is 1 times negative 2 is negative 2. Negative 6 plus 3 is negative 3. Negative 3 times negative 2 is positive 6. And 2 plus 3 is 5. 5 times negative 2 is negative 10. Finish up my x's there. I have negative 2 plus 1, which is negative 1. 4 plus 1, which is 5. And 6 plus 1, which is 7. Okay, so you know, again with 20, this value out here, this -2, negative with the y should reflect over the x, and it should be a vertical stretch. This one here is with the x, so it is a horizontal compression. So it should make it skinnier. This one up here does not have any scale changes, so this just moves to the left 5 and up 1. And this one here has a reflect over the y, and it should move left 2 and down 4. So anyway, I know that was long. Hopefully that helps. Adios.